Good day everyone, I'm Jearvely Nalual from Mandaluyong High School. You already have enough knowledge about sequences, in which a certain number is added to each term to get the next term. Now, we will explain sequences in which a certain number is multiplied to each term to get the next term. These sequences are called geometric sequence. For our objectives, we have illustrate the geometric sequence, differentiate a geometric sequence from an arithmetic sequence. What is a geometric sequence? A geometric sequence, also known as geometric progression, is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio, which is commonly represented by R. How to calculate the common ratio of a geometric sequence? To calculate the common ratio, divide any two consecutive terms of the sequence. So we have here 1, 2, 4, 8, 16. It's a geometric sequence with common ratio 2. To illustrate, we have 2 divided by 1 is equals to 2. 4 divided by 2 is equals to 2. You can also have 8 divided by 4 is equals to 2. Or 16 divided by 8 is equals to 2. So the common ratio is 2. Another one, 1/3, 1/9, 1/27, 1/81 is a geometric sequence with common ratio 1/3. So we can guess 1/9 divided by 1/3. So that is 1/9 times 3/1 is equals to 1/3. Or we can have 1/27 divided by 1/9, which is equal to 1/27 times 1/9 is equal to 1/3. So the common ratio is 1/3. How to get the next term of a geometric sequence? To get the next term, simply multiply the preceding term by a fixed number called the common ratio. So we have 1, so if the common ratio is 3, times 3, we have 3. So 3 times 3, we have 9. And then we have 9 times 3, we have 27. Now, let's proceed to these visual examples. For the first picture, we can imply that the common ratio is 1/2. Since to get the next square, we just need to take a half of the first square. So R is equals to 1/2. The second image shows that the first slice is 1/2 and the second slice is 1/6. With this, we'll divide 1/6 by 1/2 to get our ratio of 1/3. So R is equals to 1/3. Next, we have 1 and 2/3 as our first two geometric terms. That must mean that we need to divide 2/3 by 1. And we'll get 2/3 as our common ratio. So R is equal to 2/3. But what about the next picture? We can imply that our first term is the person on the top of the diagram. That means we have 1 as our first term. And since we have 2 persons on the second row of the diagram, then that must mean that we have 2 as our second term. Dividing these 2 will give us a common ratio of 2. So R is equal to 2. Now that we have a brief knowledge on geometric sequences, we'll now proceed to identifying the differences of arithmetic and geometric sequences. Arithmetic sequence versus geometric sequence. Parameter of comparison. Definition. for arithmetic sequence is described as a list of numbers in which each new term differs from a preceding term by a constant quantity. Geometric sequence. Geometric sequence is a set of numbers wherein each element after the first is obtained by multiplying the preceding number by a constant factor, calculated by arithmetic sequence, addition or subtraction. Geometric sequence, multiplication or division. Another parameter of comparison, identified by arithmetic sequence, a constant difference between two successive terms. Geometric sequence, a common ratio between two successive terms. Lastly, form. Arithmetic sequence, linear form. Geometric sequence, exponential form. Determine if each sequence is arithmetic or geometric. 2, 7, 12, 17, 22. So the common difference is 5 since 7 minus 2 is equal to 5. So it is an arithmetic sequence. Next, 2, 6, 18, 54, 162. The common ratio is 3 since 6 divided by 2 is equals to 3. So it is a geometric sequence. For the next example, we have negative 4, negative 10, negative 16, negative 22. So you will obtain a common difference of negative 6, since negative 10 minus negative 4 is equal to negative 6. So it is an arithmetic sequence. For 3, negative 12, 48, negative 192, so you will have a common ratio of negative 4, since negative 12 divided by 3 is equal to negative 4. So it is a geometric sequence. And last, 35, 25, 15, 5. So you will have here a common difference of negative 10, since 25 minus 35 is negative 10. So it is an arithmetic sequence. Please do remember to check if all the terms in the sequence has the same common difference or common ratio. The formula for the nth term of a geometric sequence. The nth term, or a sub n, of a geometric sequence with first term a sub 1 and a common ratio r is given by the formula a sub n is equal to a sub n minus 1 times r, or a sub n is equal to a sub 1 times r to the n minus 1. How to find the nth term of a geometric sequence? To find the nth term of a geometric sequence, calculate the common ratio raised to the power n minus 1. Next, multiply the resultant by the first term a. Example, find the sixth term in the geometric progression 2, 6, 18. Given, a sub 1 is equal to 2. R is equal to 3, since 6 divided by 2 is equal to 3, or 18 divided by 6 is equal to 3. N, which is the sixth term, so n is equal to 6. So using the formula of a geometric sequence, a sub n is equal to a sub 1 times r to the n minus 1, substitute the given values in the nth term formula. So we have a sub 6 is equal to 2 times 3 raised to 6 minus 1. So, calculate the common ratio raised to the power of n minus 1. So, 2 times 3 raised to 5. So, using a calculator, 3 raised to 5 is equal to 243 times 2. So, the answer is a sub 6 is equal to 486. So the next example, find the eighth term of the geometric sequence 24, 12, 6, 3. Given, a sub 1 is equal to 24. R is equal to 12 divided by 24 is equal to 1/2. And the 8th term is equal to 8. So since we're looking for the nth term of a geometric sequence, so we will use the formula a sub n is equal to a sub 1 times r raised to n minus 1. Substitute the given values in the nth term formula. A sub 8 is equal to 24 times 1/2 raised to 8 minus 1. So calculate the common ratio raised to the power of n minus 1. So we have 24 times 1 over 2 raised to 7. Using a calculator, so we have 24 times 1 over 128. So we have 24 over 128. So a sub 8 is equal to 3 over 16. So for the last example, what is the first term of a geometric sequence whose third and fifth term 20 and 80 respectively? First, solve for the common ratio r. Using t sub 3 is equal to t sub 1 times r raised to n minus 1. Then, t sub 3 is equal to t sub 1 times r raised to 3 minus 1. The third term is 20. Then, 20 is equal to t sub 1 times r raised to 2. Also, t sub 5 is equal to t sub 1 times r raised to n minus 1. So, t sub 5 is equal to t sub 1 times r raised to 5 minus 1. The fifth term is 80. Then, 80 is equal to t sub 1 times r raised to 4. Hence, 80 is equal to t sub 1 times r raised to 4 over 20 is equal to t sub 1 times r raised to 2. So, cancel t sub 1 over t sub 1. So, 80 divided by 20 will give you 4 is equal to r to the 4th divided by r to the 2nd will give you r squared. Get the square root of 4. So, square root of 4 is equal to plus and minus 2. So, the value of r is equal to plus and minus 2. And now, to solve for t sub 1, using t sub 3 is equal to t sub 1 times r raised to n minus 1. Substitute the given, t sub 3 is equal to 20, r is equal to plus and minus 2, and n is equals to 3. So we have 20 is equal to t sub 1 times the quantity of plus and minus 2 raised to 3 minus 1. So we will have here two equations. First, 20 is equal to t sub 1 times 2 raised to 2. The other one is 20 is equal to t sub 1 times the quantity of negative 2 raised to 2. If we simplify 2 raised to 2, it will give you 4. If we simplify the quantity of negative 2 raised to 2, it will give you 4. So, we have 20 is equal to t sub 1 times 4. Divide both sides by 4. So, we have 20 divided by 4 is equal to t sub 1 times 4 divided by 4. So, cancel 4 divided by 4. So, we have 20 divided by 4 is equal to t sub 1. So, t sub 1 is equal to 5. That's all for today. Don't forget to like and subscribe our channel. Again, this is Jearvely H. Nalual. The effectiveness of work increases according to geometric progression if there are no interruption. Andre Marwa.